This is 11.8, Power Series and Radius of Convergence. So far we've been talking about a lot of different tests and how to, given a series, try to figure out if it's convergent or divergent. So now you might be wondering, well, what's the whole point of all of these things? Why do we need to test? And we're slowly getting into representation of functions as series. So it'll hopefully make a little bit of sense when we get to there, but we're just gonna do one more topic and then we're gonna bring everything together. So what exactly are power series? So one of the ways that we can represent um, so we want to be able to represent some sort of function as a series, and we're gonna do that in the next couple of videos. But I'm gonna want to start off with the something called the power series. And basically what a power series is just the sum from n goes from 0 to infinity of c sub n x to the power of n. So now what we're doing, plugging in a value of x, which we haven't done so before. We've only been dealing with n. So if we were to kind of just plug in 0 and then 1 and then 2 and so on and so forth, we're going to have z0 x to the power of 0 plus c1 x to the power of 1 plus c2 x to the power of 2 plus c3 x to the power of 3 plus so on and so forth. So if I were to finish this up, x to the 0 is just 1. So we have c0 plus c1x plus c2x squared plus c3x cubed, and then you continue. Okay, so this is an example of a power series because what you're doing is that you have a constant. C can be any constant that you want. It can be a 2, a 3, whatever, an e, a pi. And then you're just having, you can kind of see it as 1 plus x squared. So if I were to kind of eliminate the c, so let's ignore the c for now. And let's just figure out what this is, x to the power of n. Then if I were to plug in the same thing, so you'll have x to the 0, plus x to the 1, plus x to the 2, plus x to the 3, so on and so forth. Then you're going to have 1 plus x squared plus x cubed, and you keep going to the x to the nth power plus keep going, okay? So notice that here, you have this particular pound, we have this x. Now, the thing is, if x is really, really large, you can kind of tell that this sum is just going to diverge, okay? But how can we make x converge to something? Well, we remember that if this is a geometric series, because this looks a lot like a geometric series, because it's to the power of n. So remember that geometric series said that if the value of r is less than or equal to 1, then it'll converge. Okay? So in this case, r will be this x. So if the absolute value of x is less than or equal to 1, it will converge. Okay? So in specific, what is this going to be? Okay? So not equal to 1, sorry. Just 1. Okay? So now and what I'm going to do is I'm going to take this absolute value. Okay, a way that we can write this is this way, because it can be positive or negative. So as long as x is between -1 and 1, it is going to converge. Okay, that's what we can say. So in general, so this was without the constant. So let's say you had a constant in there, maybe like even a shift. So if I were to have this new series, a little more general, the summation from n goes from 0 to infinity of c sub n x minus a to the n. So basically what I'm doing, I subtracted the x minus something, had a constant on the outside, and you have the power. So this is what we're going to call the power series about a. Then the power series, okay, will converge for x minus a being less than r, okay? Where r is what we're going to call the radius of convergence. Okay, so if I wanted to solve for this, you're going to get a plus r, a minus r. Okay, so that's basically what this is looking for. So first we are going to be given a power series about some value, and you know that this power series is going to converge based on this Okay. So you don't need to memorize this formula. You just have to keep in mind that this is basically how this is going to converge. We'll figure out what R is in a little bit. But this is how we're gonna do these problems. So the way that we're gonna do them is to find the radius of convergence, to find radius of convergence. Okay, we're gonna be looking mainly at the ratio test and also the root test. So these are the two tests that are really going to help us out. Okay, and the best way to kind of understand something like this is by doing a problem. Okay, so let's go ahead and start. Okay, so, oh, something else that I forgot to label. This is what we call the interval of convergence. So basically, if R is the radius of convergence of how far you are from converging, then this are going to be the endpoints, which is basically the interval of convergence. Okay, so let's do an example. Okay, now these problems can get a little lengthy, especially when you find the interval of convergence, but determine the radius of convergence and interval of convergence. Okay, and here we have summation from n goes from 1 to infinity of -1 to the power of n over 4 to the power of n, x plus 3 to the power of n. Okay, it should be -1. Okay, so at this point, what you can do, you can use either the root test or the ratio test. Doesn't really matter. Let me go ahead and just use the ratio test, but you can also use the root test. You should get the same thing. So I'm going to use the ratio test. Okay, so use ratio test. And remember that in order for me to use the ratio test, you have to find what a sub n is. A sub n is just this guy. -1 to the n, 4 to the n, x plus 3 to the power of n. If you don't know what this is an n, not a 4. Okay, so that's what a sub n is. Now let me figure out what a sub n plus 1 is. It's going to be -1 to the n plus 1, n plus 1 here, divided by 4 to the n plus 1, and then x plus 3 to the n plus 1. Okay, so now let me go ahead and use the ratio test. So you have the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. Okay, and now let me go ahead and take the limit of this, limit as n goes to infinity. So you're going to have the a sub n plus 1, which is this guy right here. This is going to be -1, n plus 1, n plus 1 divided by 4 to the n plus 1. And then I'm going to write the x plus 3 to the n plus 1 on the top. Okay, multiplied by the reciprocal of this part, the a sub n. So you're going to have the 4 to the n on top, and then everything else on the bottom. So -1 to the n, x plus 3 to the power of n. Okay, and then I'm going to finish up this. Okay, so now limit as n goes to infinity. Let's break up all of these powers. So you're going to have -1 to the n, -1 to the first power, n plus 1 stays the same. Then you're going to have x plus 3 to the n power, then x plus 3 to the first power. Okay, so I just broke up all of these different powers. Then you're going to have 4 to the n on the bottom and 4 to the 1 on the bottom, times 4 to the n on top. Everything else is going to stay the same, -1 to the n, and x plus 3 to the n. So just breaking up everything. So now notice that the -1 to the n's are going to go away. The 4 to the n's also go away. The x plus 3 to the power of n also goes away. So you're just left with a whole bunch of junk. Okay, so now let's see what's left over. So, so I'm going to have the limit as n goes to infinity Okay, so on the top, I'm going to have a negative 1 to the first power, which is just negative 1. Then I have an n plus 1, and then an x plus 3 on the top. Okay, now on the bottom, we just have a 4 to the first power, which is just a 4, and then an n on the bottom. Okay. Okay, so now this you're going to have the limit as n goes to infinity. This negative 1 is going to turn into a positive 1. You're going to have an n plus 1 because n can be all positive numbers, and so was for n. Now, x plus 3, we're not sure. We don't know what x can be. X can be a negative number. We're not sure, so that's going to stay inside of the absolute value. Okay? Now, notice here that this x plus 3 doesn't have an n. This limit only corresponds with anything that has an n. So this guy, I can just bring it outside of the limit. So we're going to have the absolute value of x plus 3, limit as n goes to infinity of this is going to be n plus 1 over 4n. Okay. So now using L'Hopital's rule, you have absolute value of x plus 3, limit as n goes to infinity of 1 over 4. So what I'm left with is just 1/4 x plus 3. Okay. All right, so is this the answer? What do we do now? Well, the thing is, when we use the ratio test will converge if the answer is less than 1. So if this thing is less than 1, it will converge. Okay, because remember, we're looking for the radius of convergence and what values of x is this going to converge? So we just used a ratio test. We ended up getting an expression. So sometimes you'll get something with x, or sometimes you might not get anything. So we know that if it's less than 1, it will converge. So all we have to do is solve this inequality. So 1/4 absolute value of x plus 3 is less than 1. Going to multiply by 4 to the other side. So x plus 3 absolute value is less than 4. Okay, so now we already can see what our radius of convergence is going to be, because if you see on the other side, right, my radius of convergence is whenever the absolute value is less than the value of r. So we already know what our r is. Our radius of convergence is going to be 4. Okay, so now we just need to figure out what our interval of convergence is. So solving this absolute value is just x plus 3 less than 4, and then also we have to put a negative 4 on the other side. So then when we subtract by a 3, so x is going to be between -7 and 1. Okay, now be very careful, because this is not the answer. We're not done yet. Not done yet. Because it seems very easy. Oh, the interval of convergence is going to be between -7 and 1. So as long as -7 and 1 is plugged into the value of x, then we should be fine. But that's not quite what we want to figure out. Because what happens if it equals -7, if it equals 1? Well, when the ratio test is equal to 1, it's inconclusive. We're not sure. So we have to check the endpoints. So let me write this in red so that you understand. We must check endpoints. Okay, so we had to plug in x equals -7 and x equals 1, and sometimes it may work, sometimes it will not get you anything, but you need to be able to check them. So we're almost done. We just need to check the endpoints. Okay, so now let's go ahead and check when x is equal to -7. Okay, so we're going to check this endpoint right now. So we know that the summation from n goes from 1 to infinity of -1 to the power of n divided by 4 to the n of, what was it, x plus 3 to the n. Okay, so now what we're going to plug in, we're going to plug in -7 in there. Okay, so we're going to have the sum from n goes from 1 to infinity of -1 to the n, 4 to the n, -7 plus 3 to the nth power. So we're going to have the sum from n goes from 1 to infinity of -1 to the n over 4 to the n, and then this is going to give me -4 to the n. Okay, so now one thing that we can do with this summation from n goes from 1 to infinity, okay, so this whole thing is going to stay the same, Now, one thing that I can do, let me take out a negative 1. So what I'm going to do is I'm going to take out that negative 1 to the nth power, and I'm going to have 4 to the n. Okay, so this negative, I can actually take it out, but remember there's an n there, so I have negative 1 to the n, so this makes it a positive 4n. And this is really nice because now you can see that the 4n's are going to cancel out. Okay, so now all I'm left with is just a sum from n goes from 1 to infinity of negative 1 to the n, negative 1 to the n times n. Okay, well, negative 1 times negative 1 is going to give me positive 1. Okay, so that's all I'm left with is the sum from n goes from 1 to infinity of m. Okay, so this series, we can just use a divergence test. Okay, so we're going to use divergence test. Okay, so we're going to take the limit as n goes to infinity of n, and this is just going to give me infinity, which is not equal to 0. Therefore, the sum from n goes from 1 to infinity of n diverges. So because it diverges, that means that at x equals negative 7, it will diverge. Okay, so that means I will not include this negative 7. Okay, so the negative 7 is not included. Okay, so it should be a less than. Okay, now is the 1 gonna be included? Well, we have to check the 1 also. Okay, so now let's go ahead and check x equals 1. So let's plug in x equals 1 now. So when you plug in x equals 1, we're gonna have the sum from n equals 1 to infinity, negative 1 to the n, n over 4 to the n, negative 1 to the n. Oh, that, no, whoa. X, what was it? X plus 3 to the nth power. Okay, now we're going to plug in x equals 1. Okay, so sum from n equals 1 to infinity, negative 1 to the n, n over 4 to the n. Plug in the 1 plus 3 to the n. So you're going to be left with the sum as n goes from 1 to infinity, negative 1 to the n, n over 4 to the n. So this top part is going to be 4 to the n, and you can see that the 4 to the n's are going to go away. So all I'm left with is n1 infinity, negative 1 to the n times n. Okay, and now at this point, you can use the alternating series test, but notice that n, your b sub n, is not going to be decreasing. So one of the things that you should maybe do is just use the test for divergence. So I'm going to use the divergence test again. Okay, so what we're going to do is we're going to take the limit as n goes to infinity of this whole thing, taking negative 1 to the n of n. Notice that when I plug in infinity in here, this is just going to be alternating, okay? So that means that if I were to kind of look at this, here's 1 and here's negative 1, this thing is just going to be alternating back and forth. So the limit isn't ever going to go anywhere. So here the limit does not exist. Okay, so because this was not equal to 0, okay, by divergence test, the sum from n goes from 1 to infinity of negative 1 to the n diverges. So because it diverges at x equals 1, it will diverge. Okay, so what we can say is that our radius of convergence, if we go back up to our original problem, our radius of convergence is going to be 4. And our interval of convergence is going to be between negative 7 all the way to 1. Okay, now sometimes they might equal and they might converge. So but you always have to make sure that you check the endpoints, okay? Because the endpoints are going to be very, very important.